Welcome to A6, example 1. In this example, we're going to substitute a value or a letter A to replace any constant. So here we're taking a look in the opening exercise. In exercise 1, we saw problems like this: x squared minus 144 divided by x minus 12. And we're going to replace the 144 and the 12 with an A value. Right? 144 is just A squared, and A is just 12. And so, what is A? So we've been using the reverse table method to compute quotients, just like the ones we've seen in the opening exercise and in exercise 1. And so we're going to replace the number with that letter A. Why do we do this? We do this because it can verify the patterns that we've noticed for any value of A. And we're actually going to be able to conclude at the end of the lesson this generalization for any division problem where it's x to the nth power minus a to the nth power divided by x minus a. So we're going to transition over to looking at this problem, and we're going to use the reverse table method. So we're going to use this reverse table method, and I have it set up here. The divisor always goes on the right hand side of the table. The top, the dividend, is what we would pull out of this table. And so now we have to figure out what goes up here, right? This is where the quotient is in our problems. So x squared is here, and negative a squared is here. And just by doing that, we figure out that this must be x, and this must be a, because a times negative a is going to get you negative a squared. And so your answer here is x plus a. And so that is the quotient to this division problem. So what is the quotient of x squared minus a squared divided by x minus a? Well, from doing the reverse quotient method, or the reverse table method, excuse me, we find that the result is x plus a. And so we have just summarized the pattern. If you go back in your notes and you take a look at these three problems, the opening exercise, exercise 1a, and the example 1 that we just did, you will see this pattern appear in all three of those cases. And so we can say for all problems like this, the quotient will be x plus a.